Assalamualaikum and good day. Uh, Today we are going to continue our topic of fuzzy logic, fuzzy expert system, okay? And we are going to study fuzzy inference. Okay, first of all, we are going to study Mamadani fuzzy inference, and then we go for Sugino fuzzy inference. There are a big difference between these two inference being used for fuzzy. And we are going to look to case study. And if I'm not going to discuss this, maybe I will let you to understand it, go through it. Most probably, I will make one of the assignment based on this case study. And then we go for summary, which we make a comparison between these two inference fuzzy, and hopefully you understand to which, uh, if you are going to use fuzzy expert system, which fuzzy inference that's suitable for your application. Okay, this is the first introduce of fuzzy inference, which we call it as Mamdani. Actually, before that we have already, but this is the one that being used widely. Okay, it being introduced by Professor Ibrahim Mamdani from the London University on 1975. Okay, which he used it to control a steam engine, a boiler, a combination of these two, where he applied a set of fuzzy rules supplied by experienced human operator. Okay, as I mentioned to you, in order to develop the artificial intelligence, one of the main important thing is to have an expert domain to help developing the system. Okay, the Mamdani style fuzzy inference process is performed in 4 steps. So you can follow these 4 steps. It is quite straightforward to be used. Okay, the first one is fuzzification of the input variable. Okay, you have an input and then you have an output. So in the first step, you need to do a fuzzification of the input variables, and then you need to evaluate the rule evaluation, and then aggregation of the rule output. Okay, you are going to, after you evaluate the rule, then you start to aggregate the rule of the output, and finally you make a defuzzification. Okay, we're going to look at the examples. Okay, let me examine a simple two input, one output problem that includes 3 rules. Okay, you have 3 rules, and then you have 2 output and 2 input and 1 output. Okay, this is the first rule. Okay, the first rule, if A is A3, okay, if A is A3, or Y is B2, then Z is C3. So if you look from here, you have 2 input, it is A and B, while C is the output. Okay. This is examples of uh, we apply it to certain application. Okay. If the project funding is adequate or use a conjunction or project staffing is small, then the risk is low. Then we have the second rule. If X is A2 and we use a conjunction and Y is B2, and then we have Z is C2. So in this application, we put if project funding is marginal and project staffing is large, then the rule is normal. Use a conjunction and. And the third rule is if A3 if X is A1, then Z is C3. We have only one in the third rule, only one input and one output. If a project funding is inadequate, then the risk is high. Okay, these are the rules. Then the first step is uh, as we have all the four steps. This is the first step. How to make a falsification. Okay, the first step is to take the CRIPS input for X1 and Y1 for project funding and project staffing. Okay, we have two input, okay, X and Y, and the first step is to take the CRIPS input and determine the degree to which this input belong to each of the appropriate fuzzy set. Okay, we going to have a fuzzy set, and then we will determine the degree to which this input belong to each of the fuzzy set. Okay, if you look, this is the CRIPS. Okay, if you look, this is the first input. Okay, this is the project funding. Okay, you have three set. What we call the first one is adequate, marginal, and then we have the inadequate. Okay? And then this is the second input. Okay? We have stuffing, project stuffing, enough and small and enough. I'm not sure this one, okay? But we have two set. Okay, as I as we try to find the CRIPS input, is the function of x a1 is equal 0.5, okay, and function set of a2 is 0.2. Okay, if you look here, the CRIPS set of the input x1, if uh, the CRIPS set, it is a straight line, one single value of uh, the project funding. Okay, so the set for adequate in this x1 is 0.5, while for marginal is 0.2. Okay, in the second input, if you look here, where we have scripts input y1, is y1. We have a small and large project stuffing. Okay, for large project stuffing is 0.7, and for low project stuffing is 0.1. This is what we mean by fuzzification. And the fuzzy set, as we know, is determined by the expert domain. And then we start to do the second step, the rule evaluation. Okay, as we know, the second step is to take the fuzzified input, uh, for A1 is 0.5 and for A2 is 0.2. While for the second input, we have yes, and for the second input, we have B1 is 0.1 and B2 is 0.7. And then we apply them to antecedent of the fuzzy rules. If a given fuzzy rule has multiple antecedents, okay, for example, the fuzzy operator either and or is used to obtain a single number that represent the result of the antecedent evaluation. Okay, this number, the truth value, is then applied to the consequent membership function. How we apply it? Okay, uh, if in the case of to evaluate this function is or fuzzy operation of the rule antecedent, we use the or fuzzy operation. Typically, fuzzy expert system make use of the classical fuzzy operation union. So if we are going to use or, then we are going to choose the maximum between these two uh, sorry these two input. Between these two input, we are going to choose the maximum one. Okay, and similarly, in order to evaluate the conjunction of the rule antecedent, we apply the AND fuzzy operation insertion, where in AND fuzzy operation intersection, okay, this is the mathematical representation, we are going to use the minimum between these two inputs. Between these two inputs, okay, we are going to select the minimum one. Okay, if you look here, okay, this is the first rule. Okay, the first rule, if X is A3, okay, since A3 in the Cripps selection, it is 0, or Y, or we use this conjunction, or Y is B1. Okay, Y is B1. Okay, in Y B1, the value is 0.1 at Y1. Okay, you look at B1. Okay. This is the rule. The rule, because we set up already the rule. Okay, for the first rule, A3, if we look 0.5, we don't have here. So that's why it is 0. For B1 in the Cripps input, uh, B1, the value is 0.1. Then, since we are using the OR, this function, then we are going to use the maximum one. Between 0.1 and 0.0, 0.1 is the maximum one. So we are going to select 0.1 for the rule number 1. And if we look at rule number 2, if x is a2, okay, when we look at x is a2, in the first input, next input, x1, where we get, if x is a2, it is 0.2. And we are using the n conjunction n. And y is b2, and we check at b2, y is b2, it is 0.7. This is 0.2, and for b2 it is 0.7. Since it is n conjunction, so z we are going to select the minimum one. So between 0.2 and 0.7, 0.2 is the minimum one. Okay, the minimum one. And then for the third rules, we have if x is a1, x x is a1, then the value is 0.5. Then we take directly the value of z is 0.5. Okay. This is the part where we evaluate the rules. Okay, now the result of the antecedent evaluation can be applied to the membership function of the consequent. Okay, where the most common method of correlating the rule consequent with the true value of the rule antecedent is to cut the consequent membership function at the level of the true antecedent. Okay, this is what we call clipping. Okay, since the top of the membership function is slide, the clipped fuzzy set loses some information. Okay, however, clipping is often preferred because it involves less complex and faster mathematics and generate an aggregated output surface that is easier to be falsified. Okay, we look at the example how. Okay, while clipping is frequently used method, we have another method where we call scaling, which offer a better approach for preserving the original shape of the fuzzy set. We have two method. Okay, the first one is the scaling, sorry, slicing, and the second one is the scaling. The original membership function of the rule consequent is adjusted by multiplying all its membership degree by the truth value of the rule antecedent, where we find that this method we generally lose less information and can be very useful in the fuzzy expo system. how we do it. Okay, click and scale membership function. Okay, this you look at Z, Z, the output. Okay, this is how you use the sorry, the clip, the clip membership function. Okay, it is less mathematical calculation compared to the scale. Okay, the scale you need to adjust it at 0.2. Okay. Okay, and then we go for the step 3, aggregation of the rule outputs. Aggregation, okay, is the process of unification of the output of all rules, okay, where we take the membership function of all rule consequence previously clip or scale, okay, it depends on you, which one that you want to select, and combine them into a single fuzzy set. Okay, you have to develop into a single fuzzy set. The input of the aggregation process is the list of clip or scale consequent. Okay, consequent. So the output membership function, and the output is one fuzzy set for each output variable. One fuzzy set. We have how many? Three output variable. Then we can have one of each one. Each of these fuzzy set you have one. Okay, aggregation of the rule outputs. This is for the first C1. Okay, C1, actually we have C1. If we look back at our first rule, okay, we have C1 is 0.1. Then for the second one, uh, for the second rule, okay, it is 0.2, and the third one is 0.5. So the aggregation of the rule output, we combine it all. Make a summation of all of it. So we have 0.1, 0.2, and 0.5. Okay, this is the last step. Okay, it is a defuzzification. Okay, the last step in the fuzzy inference process is a defuzzification. Okay, fuzziness help us to evaluate the rules, and actually at the last step, the final output of the fuzzy system has to be a Cripps number. If you need to only have one Cripps number. Okay, the input for the defuzzification process is the aggregate output fuzzy set, the one that we get it from the previous step. And then the output is only a single number. Once you complete the step of defuzzification, you only have one single number. Okay, there are several defuzzification methods, but probably the most popular is the central technique. Once you have the aggregation of the rule, when you want to make a defuzzification, you have a numbers of defuzzification, but this is most popular. We call it as a central technique, a center of gravity. It finds the point where a vertical line would slice the aggregate set into two equal masses, okay, where in mathematical we call it as a center of gravity, and we can express it as, okay, this is a center of gravity. Okay, we integrate it, the function of the first one over x, and divide by the function of the first input. Okay, centroid defuzzification method finds a point representing the center of gravity of fuzzy set A on the interval between the interval of A and B. We integrate it between A and B, fuzzy set of A. So a reasonable estimate can be obtained by calculating it over a sample of a point. So you want to make it average. Okay. Then you divide it by sample of points. Okay, these examples. Okay, this is for the fuzzy set A. Okay, you have between A and B, and then you make the integration over all of the, and then you divide by by the interval. Okay, this is the one that we have discussed, the example that we have discussed. Okay, we have the first one, 0 plus 10 plus 20, you multiply by 0.1. Okay, okay. Sorry, we continue again. As we know, the center for gravity in Mamdani, we integrate all of the set. Okay, as we know, okay, the first one is we have the value of 0, 10, 20. We need to multiply by 0.1, and then the second set and the third set. Okay, if you look here, we take all the value, and then we going to divide by all the. So at the end, the center of gravity, as I mentioned, that we only get one value. So this is uh, the classification steps. Okay, in the Sugino fuzzy inference, okay, where in Mamdani style inference, as we just seen, required us to find the centroid of two-dimensional shape by integrating. So you need to do the integration across a continuous varying function. So it is, there are a lot of interval between the is going to be more mathematical computation required, shaped by integrity across the continuous varying function. So in general, this process is not computationally efficient. Okay? If you have a number of interval, it becomes more complex. So Michio Sugino suggested to use only a single spike. You only use a single turn as a membership function of the rule consequent. Actually, we look at the rule consequent in order to get the value. A singleton, or more precisely, a fuzzy singleton, is a fuzzy set with a membership function that is unity, only one numbers, at a single particular point on the universe of discourse, where we consider it zero everywhere else. Where in Sugino style fuzzy inference actually is very similar to the Mamdani method. Sugino changed only a rules consequent. Instead of a fuzzy set, he used mathematical function of the input variable. Okay. The format of the Sugino style fuzzy rule is as below. Uh, we have if x is a and b is y is b, then z if a function of x and y, where x, y, and z are linguistic variable. All of these are linguistic, and a and b are fuzzy set on universe of discourse x and y respectively, and function of x, y is a mathematical function. Okay, the most commonly used zero-order Sagino fuzzy model applies fuzzy rule in the following form. If x is a and b, y is b, then z is k, where the k we consider it as a constant. So in this case, the output of each fuzzy rule is constant. We only consider one value. All consequent membership functions are represented by singleton spikes. From the fuzzy set, we only consider only one value. Okay, so in the Sugino style rule evaluation, then we can write it. We can consider it as, okay, we have the first rule. If x is a3, it is 0, and or with y is b, where b is 0.1, and the value is 0.1. So when uh, we consider the what we call this conjunction in the rule, then the z is k1, the first k, it is 0.1, only one value. In the second rule also, we have if x is a2 0.2, y we add it, it is n conjunction is or is conjunction, y is b2 is 0.7 for n, then we will choose the minimum one, then we will choose the 0.2, so only one 0.2. In F, in rule number 3, if x is a1 0.5, then we consider it 0.5. So, Sugino style aggregation of the rule output becomes, we have z is k1, and then we have the second rule, z is k2 0.2, and z is k3, value of k3 is 0.5, then we make a summation of all of it. Okay, and then we use a weighted average. Okay, this is average. We take an average between the interval. Okay, for the first rule, we take the average is 20. We have 0, 20, 30. Then we have 20. For the second rule is 50. We have 40, 50, 60. So it is 50. The average. And for the third rule, it is 80, 70, 80, 90, 100. So at the end of we got 65. So the Crips output of the Sugino style defuzzification is at 65. Okay, if you look the difference between Mamdani and Sugino is a bit about 2. So for Mamdani is 67, 2+%. Okay, so how you want to make a decision on which method that you want to apply? Either you want to use Mamdani or Sugino. There will be no exact step that you can choose. Okay. No general rules. But you need to understand, Mamdani method is widely accepted for capturing expert knowledge, which it allows us to describe their expertise in more intuitive, more human-like manner. Where, however, Mamdani type fuzzy inference entails a substantial computation burden. Means it requires really complex mathematical solution and is really computational complex. While in the Sugino method, okay, Sugino method is computationally effective, where it works well with optimization and adaptive technique, which made it very attractive in control problem, particularly for a dynamic nonlinear system. Since dynamic nonlinear system, the interval is much more wide. Okay, okay, so these are the different. Okay.